No part of the surface of our Earth is as vast or as mysterious as its oceans. The water of the Earth's oceans covers more than 70%, or nearly 3/4 of the Earth's surface. This one great body of water is made up of the Pacific, the Indian, the Atlantic, the Arctic, and the Antarctic Oceans. Only within the last century have these oceans been carefully and accurately mapped. Primitive sailors stayed very near shore and used the oceans mainly for fishing. In ancient times, Mediterranean peoples, such as the Greeks, built ships and sailed them along the coasts of Europe and North Africa. This copy of a map, drawn by an early Greek mapmaker, shows how little was known about the Earth and its oceans. By the 17th century, even though maps were still very inaccurate, skilled seamen were able to guide their ships regularly across the vast oceans. And yet, after nearly 2,000 years of exploration and travel, men knew less about the vast rolling ocean than about any other part of the Earth's surface. Scientific investigation of the ocean was begun by men such as Matthew Fontaine Maury, an American naval officer. In the middle 1800s, many ship captains brought Maury information about the oceans from all over the world. By studying mariners' records of ocean voyages, Maury collected accurate first-hand information, which he organized and published in a book, The Physical Geography of the Sea. This book was a major contribution to a new branch of science called oceanography, the study of the Earth's oceans. Many different specialized branches of science contribute to oceanography. Among others, these include biology, chemistry, physics, and the earth sciences such as geology and physical geography. Often, ships are equipped as floating laboratories to study the ocean firsthand. Aboard ships such as this, oceanographers trained in geology and other earth sciences use special instruments to study the bottom or floor of the ocean. One way in which scientists can study the contour of the ocean floor without going underwater is by using instruments such as this echo sounder. The sounder records a graph showing the contour of the ocean floor. As sound waves from the sounder bounce off the ocean floor, a record of the distance between the ship and the floor is made. Such records show that the major topographic features of the ocean floor are much the same as those of the continents. A coastal region of shallow water called the continental shelf is an extension of the continents. The continental slopes at the outer edge of the shelf form the sides of the deep sea basins. Within these basins are many trenches, in places extending downward more than 6 miles below sea level. Towering undersea mountains sometimes rise above the ocean surface to form islands. Actual samples of the ocean bottom can be obtained with certain instruments. This instrument, called a corer, plunges downward into the ocean floor when lowered from the ship. When the corer is brought up, it has inside a sample of the ocean floor called a core, which can be studied. Often the cores consist of ooze, a soft, mud-like deposit of sediment. Samples of the contents of the core can be removed and viewed with a microscope. The shells of tiny microscopic sea creatures which have fallen to the bottom for millions of years are part of the sediment which covers most of the ocean floor. Sediment is also added by rivers, by ash from volcanic eruptions, and by dust blown from the land. For millions of years, layer after layer of loose sediment has been added to the floor, forming a thick deposit near the continents, sometimes several miles thick. Pressure and chemical change over a very long period of time consolidate this material into sedimentary rock. Most of the rock exposed at the Earth's surface is sedimentary rock. Since this rock was formed beneath the ocean, we know that ocean water long ago covered large parts of the continents. Petroleum, a valuable resource, is found in some sedimentary rock formations. Thus, by investigating how sediment is deposited, scientists may find new petroleum resources. The study of the physical properties of the ocean water concerns physical oceanography, another branch of science. One significant property of ocean water is its temperature. Using specially designed thermometers to measure water temperature at different depths, physical oceanographers have found that the temperature of water partly determines its movement. As surface water is unequally heated by the sun, and as winds blow across the water, moving streams of water called currents are maintained. Swiftly moving currents, such as the Gulf Stream seen here, are something like tremendous rivers flowing in the oceans. Because such currents may carry either warm or cool water, they may influence climate when they flow near land, making the weather warmer or cooler than it would be without the nearby current. Waves are another feature of ocean water. Scientists study how waves are formed and how they travel. Observations of such movements of water can, at times, help weather experts to locate storms approaching land from the ocean. So information about waves sometimes supplements the data used by meteorologists in predicting weather. Tides are an unusual feature of the oceans. High tide, seen here, and low tide occur nearly twice each day in all the oceans of the world. Still another feature of the ocean is the great variety of living things it contains. The study of life in the ocean is called marine biology. The marine biologist often collects specimens of ocean life along coasts. Many different animals and plants can be found upon the beach or in the shallow coastal water. In tropical water, colorful plants and animals are found, including fish of many shapes and sizes. Here are found unusual creatures such as the sea turtle and the strange-looking octopus. Among the thousands of varieties of ocean fish, man has found many which are valuable to him. For instance, ocean fishing is an important industry in many parts of the world because man has discovered that fish and other living things in the ocean are a source of nutritious food. Even marine plants, such as kelp, have value as a source of food. In recent years, many kinds of valuable products, including iodine, are being produced from sea plants such as these. Seawater is a storehouse of many different mineral salts. If we fill a dish with seawater and let it stand until the water evaporates, we find that a deposit of mineral salts remains. Factories such as this extract common table salt in quantity from ocean water. At this plant, seawater is evaporated in large artificially made ponds. As the water evaporates, the salt separates out as crystals. There is over a pound of common salt in every 5 gallons of ocean water. The water in the ponds is checked regularly to determine the salt content in solution. One of the most useful metals that can be obtained from seawater is magnesium. In plants such as this, magnesium salts are obtained from seawater. These salts, which are metallic compounds, are processed to produce the metal magnesium. In 1 cubic mile of seawater, there are about 4 million tons of magnesium, making the ocean an abundant source of this metal. Magnesium is used to make aircraft parts and in other industries where a strong, lightweight metal is needed. We've seen that our growing knowledge of the oceans, gained from different branches of science, is adding information to our relatively new branch of science, oceanography. Besides adding to our present scientific knowledge, the study of the oceans may help us solve problems in the future. The ocean presents man with immense challenges. How can man's increasing need of metals be filled from the ocean's vast store of minerals? How can weather forecasting be improved by a better knowledge of how the oceans affect weather and climate on the continents? How can foods from the ocean be obtained in greater quantities for the Earth's rapidly growing population? Answers to questions such as these must come from our increasing knowledge of the Earth's vast, deep ocean.